Here we have the formula for the population variance. This is the formula we just derived. We take each data point and subtract the mean. We square it, add them all up, and divide by the number of pieces of data. So it's the average of the squared distances from the mean. If we had a sample rather than a population, the division is by n-1. You don't need to understand why at the moment, and most exam boards will not mind whether you calculate dividing by n or dividing by n-1 if you're given a sample. However, the correct way is to divide by the n-1 when you have a sample. Note here that the sample variance is called s squared, whereas the population variance was called sigma squared. Also note in the top formula for population, the population mean is called mu, where the sample mean is called x bar. By algebraic manipulation, the original formulae can be changed into these ones. The top one here would be used when calculating using discrete data, and the bottom one would be used when working with a frequency distribution. The reason we use these formulae, rather than the original derived ones on the left, is that calculation is very much simpler using the formulae on the right. They look very complex, but the practicality of actually working out variance and standard deviation is not complex, as we'll see over the next few examples. Of course, we must remember, as mentioned, the standard deviation is the square root of the variance. All of the formulae above are formulae for calculating variance. If we want standard deviation, we perform these calculations to find the variance, and then take the square root.